Hello there and welcome back to this video series on control systems. Before we jump into the video itself, we'll do a quick review of what we have seen earlier. In the standardized form of a block diagram for a closed loop control system, there are four components. One is a comparator, then the regulator, then the system to be controlled, and then the feedback. Of course, if there are disturbances, they need to be shown separately. After watching this video, you'll be able to write equations for elementary block diagrams and then explain what we mean by transfer function. With that, we'll jump into the lesson of the current video. Consider the closed loop block diagram shown over here. In this, we see that each rectangular block represents a subsystem of the overall system. This whole block diagram represents one system, of which regulator is one block, comparator is one subsystem, the system itself is a subsystem, then feedback along with all conditioning circuits or any other control circuits forms one subsystem, and each in some sense represents a mathematical operation. Because we are saying something about mathematical operations, we are using symbols. R indicates reference input, M indicates manipulated variable, C indicates controlled variable, and O indicates output of the feedback block. Further, we see that this circular block with signed arc segments, that is, there is a positive sign for R and negative sign for O. This in some sense indicates that E is a combination of two variables, R with a positive sign and O with a negative sign. That is, E is equal to R minus O. That is what we mean. This circular block with signed arc segments is comparator. And each rectangular block in some sense indicates multiplication. With that, we'll try to further see how we can generalize it a bit more. The top one shows the diagram we have with names in it, and this bottom diagram is a brief and yet generalizing statement. This regulator we are representing by symbol T, and then the system we are using the symbol capital S. This feedback we are representing by capital H. Capital T, capital S, and capital H are three systems. Okay. Later we will see that this T is called the transfer function of the regulator, S is called the transfer function of the system, H is called the transfer function of the regulator. With the symbols that we have already agreed on, R is the reference input, E is the error, M is the manipulated variable, C is the controlled variable, O is output of the feedback block. That's what we said. This T represents regulator, then S represents system, and H represents the feedback. We'll try to associate mathematical equations corresponding to each of the blocks as shown in the slide here. Okay, let me run it from the beginning. Okay, this is the block diagram we have, and then we are focusing on comparator, and then the equation for comparator is R with positive sign, E with negative sign. Then the next element we have is the regulator, this regulator with block T. The equation is output is equal to E multiplied by the transfer function T of this block. That is, M is equal to TE, output is equal to input multiplied by something, is the equation. And this we say is the regulator. Then the S block represents the system. For system, the equation is again output is equal to input multiplied by transfer function. C is equal to SM. This is what we call the system. And then the last block we have is the feedback element, for which again output, that is this O coming out of the block, is C multiplied by input, and this we call as the feedback element. We'll try to write all the equations at one place systematically. That is, we say for the comparator it is E is equal to R minus HC, because this O is HC. Then we have for the regulator M is equal to TE. For the system, C is equal to SM, and for the feedback we have O is equal to HC. Now we have a generalized block diagram and a set of equations. We call it generalized block diagram because this can apply to a temperature control system, this can apply to a speed control system, this can apply to a position control system, and in fact any closed loop control system that we can think of. R is the reference input, then E is the error, M is the manipulated variable, C is the controlled variable, O is the output of feedback block. This applies to any system. It may be reference speed, reference temperature, reference acceleration, and so on. This E is the error in the speed, or error in the temperature, or error in the acceleration. The mathematical equations are all the same for any given situation. That is why we say it's a generalized block diagram. Now we'll try to see and introduce the term transfer function in a bit more formal way. For the regulator, you have this M is equal to TE, and you represent it as a block diagram indicated over here. We call this T as the transfer function of the regulator. Similarly, this S is what we call the transfer function of the system, and then this H is the transfer function of the feedback. In each case, you can see this transfer function T is defined as ratio of M to E. This S is defined as ratio of output to input. This transfer function H is C O over C. O is the output, C is the input. In passing, we note that though it appears to be similar to efficiency, do not be led to think that this transfer function is efficiency. We'll try to see what is this transfer function, what is its significance in subsequent videos. Before we close, we'll try to see something about this comparator. This comparator in a generalized block diagram is represented as a summing block. The summing block is what we represent by a circle with sectors in which we put either a positive sign or negative sign. Let us see that here. One we have already seen, plus R minus O is equal to E. E is equal to R minus O. Similarly, we can see a second example here, that is you have the summing block here, and E with positive sign, D with positive sign, and Y output. So Y is equal to E plus D. Similarly, you have a block diagram consisting of two blocks put in series. This summing block 1 and then another, this summing block 1 and another summing block. So you have Y is equal to D plus E, and then Z is equal to Y minus W. So the Z output of this whole two blocks put together is E plus D minus W. I think that's all we have for now, and we summarize this video as a comparator is shown as a signed segmented circle. Each rectangular block represents a transfer function, and then rectangular block indicates multiplication in some sense. For each mathematical block, for each block diagram, we can write a set of equations. I think that's all we have for now. Have a great day.